Okay, we're going to start on linear equations tonight. Linear equations mean equations that when you graph them, they create a line. Okay. Hence the root word. This is called standard form, where A, B, and C are numbers. Okay. That is not our favorite format. There's a better format that's kind of a working format, whereas this is kind of the tuxedo format, and the other one's the coveralls format. And we'll get to it a little bit later. This just says that these are real numbers and A and B are not zero. Well, if A or B were zero, then you would be missing a variable. Okay. By the way, anyone who took one of my citations handout, that's for the other class. Yours is on a video, which I already have posted for you, the link. Now, in this case, graph the equation and identify the X and Y intercepts. The X and Y intercepts are the locations where it crosses the Y axis, it intersects the Y axis, or it intersects the X axis. Now, if they ask you that question, then your answer must be in a point, an XY coordinate point. If it's not, it will be a deduction. If you just give me the Y value without giving me the associated X value, which in the case of a Y-intercept would be, X would be zero always. On the Y-intercept, X always has to be zero because it's on the axis. On the X-intercept, Y always has to be zero. Now, in this particular case, the way they get these values is just based on what I just told you. To find the X-intercept, okay, where it crosses this line, the Y value has to be zero. So we replace that Y with a zero. They didn't show that. They showed that substitution. 3x minus 2 times 0 equals 6. Okay, for the Y-intercept. Well, you solve it on down, so that gives you the point to 0. X is 2, Y is 0. So, oh, that's the X-intercept rather. So in other words, in this X-intercept, right here is the value of that X-intercept, that point, the 0.20. Now for the Y-intercept. Again, they left out part of their steps. This time you got 3 times 0 minus 2y equals 6. Okay, because we're looking for the Y-intercept, X has to be 0. So we replace it, solve it, and we get the 0.0, -3 here. And the line associated with those two intercepts would be that one. Okay. By the way, anytime you draw me a graph on a problem that I require it on, unless it's a real shallow line that would have to go forever to hit the X or Y axis, always make sure it crosses both axes, because basically that's how I grade it. So any questions about this? Okay, this one happens to be a very special one. Well, we're going to divide both sides by 5. Okay, and we're going to get X equals -2. Now, you notice here that the X-intercept is the point -2, 0. But this is the equation simplified And what that means that x is always -2, no matter what y is. Listen to my wording on this. X is always -2, no matter what y value you were to pick. So I could pick this value, I could pick that value, I could pick that value. What we've got, when it's in this format, is a vertical line. Okay, now, since we're kind of talking about that, I'll go ahead and hit this. If you have an equation like y equals -5, no x shown. Okay, no x shown. Then that means the y value is always 1, 2, 3, 4, 5, no matter what value of x you were to choose. Or in other words, this is the general format of a horizontal line. Okay, horizontal, vertical. And we'll hit that in a little while. But this seems like a good opportunity. Okay, now, the horizontal line only has a y-intercept, no x-intercept, unless it's on this line. A vertical line has no y-intercept unless it is on that line. Okay? And there it is. Okay, here. What kind of a line did I tell you that's going to be? A horizontal line, okay? At y is 2. The intercept, because it never crosses it. The y-intercept in this case is 2, or simply the point 0, 2. If it asks for the term y-intercept. Questions? Okay, here are some more. We can do those, or we can go on. Your call. Any of these you'd like to see? The question is find the, just simply graph it. Well, let's do, since all it says is graph, let's do at least 1 or 2 of these. The first one. Okay, in this case, if I let x equal 0, okay, so if I let x equal 0, then I have the point 0, 1. There's the y-intercept. Okay. Now, let me graph the x-intercept. For x plus 2 times 0 equals 2. Okay, so for x equals 2, x equals 1/2, gives me the point 1/2, 0. Okay, so 1/2, 0 right there. And here is that line. What kind of a line is this going to be? Horizontal. At 1. What kind of line is this one going to be? It's going to be vertical at -3. Or, excuse me, 3 goes into 12 4 times. So it should be -4. We'll call this 4. Okay. Okay, slope of a line. That's kind of hard to read, so let's go to this one. We might think of slope as rise over run. Rise over run. Very important phrase. That means how much it increases in height compared to how much it increases sideways. So in other words, the slope of this is we take how much it changes up and down and how much it changes across. And we express that either as a fraction, decimal, or percent. When you're talking about highways, they say percent of grade. Okay. Of houses, you might have a 612 pitch, a 412 pitch, a number of different fractional pitches. In graphs, sometimes you use decimals, especially if it's in industry showing growth rates. Okay. Well, the amount of change in Y or the amount of change in X. Now, if I give you 2 points on a line, this part, by the way, that delta, that's a Greek letter delta, means the change in Y values and the change in X. So what we're doing is we got these 2 points, we're subtracting one from the other in the same order. If we start with this Y value followed by that one, then we must use this X value followed by that one. Now, we could make this Y1 minus Y2, 1 minus Y2 just as easily. This business is saying we can't have a zero denominator. And by the way, if we ever do a zero denominator, that's a vertical slope. Oh, what's this? Well, that's the Durango-Silverton Railway. That's me. My daughter took this picture, hanging out the window like these other fools. Down here, 400 feet down, is the Animas River. It's a class 4 rapids river. Okay, class 5 is the worst. Now, when this train left the station in Durango, it was 10 feet above the water level. Now it's 400 feet. On a railroad, 3/2 or 1.5% is all you can do. Now, how much are we talking about? From this wall to the third classroom down is approximately 100 feet, because each one of these is about 30 feet. A little more than that. Okay. That means that you can only have an increase in level of 18 inches from here to there. And if you have more than that, chances are the engine's going to spin its wheels. Now, they have what they call sand domes on them, where they can drop sand on the track right in front of the wheels to help traction. They also can add additional engines, which puts more surface on the track, or they can reduce the number of cars in order to keep going. I happen to have a garden railway. That's in my backyard. In this case, the rise from here to here, each one of these cars is about 6 inches tall. Okay. So if we compare here, I'm more than a foot higher. Okay. If I tried to go straight from here to there, which is only a distance of about 6 feet right at that particular point, that would be way too steep of a slope for that little engine to pull it. And that's one of the heaviest built steam replica engines that they make. That one's a pretty heavy duty. I pulled 40 cars with that one. Now, what I did was by putting this curve in here, or switchback if you prefer, I increased the run compared to the rise. Got it down to a level where the engine could actually do it. Now here's another illustration. At one time here was my home station, and that was a pretty steep, that was more than a 2% slope from there to there. And since the engines were stopped at the station, they'd have trouble getting going with that steep slope, particularly if I had several cars on. So, pull up the track, put this 1.25 inch thick, actually PVC lumber, wood, underneath the track, and then refilled it with gravel. So it looked pretty. Now, my increase is just slightly more than 1%. And the trains have no trouble with it. That's just another picture of it. This track is actually level, and as this goes uphill, those two eventually meet over here. Likewise, they have a meeting point, and there's another track back up here too that comes around. At one point, I had a real low point, and I had a 4.7% grade that I had to deal with. Ran just fine going downhill, but didn't do very good going uphill. So I built this trestle. This is the beginnings of a trestle that I built. When I got done with this, it had an 8% grade. Now, this is that trestle I showed you in the last slide, where I put the fascia under it. Okay, made it look like a trestle. Here I'm building another link, and this will eventually become a viaduct. All of this is level. Now, see that string right there? That's the level. Right this minute, it's not. Now, here's this part of that right there is now this. Whoops. Keep going through this, a viaduct. And then here is that curve you saw before. Over that plastic wood you saw, I stung 1/4 inch mesh wire and used a mixture of stucco and concrete mix, ready mix, with dye in it to put it there. Now it's all kind of mossed in and stuff, and it makes it look much more realistic. There are actually tire tracks imprinted in this little roadway right here. Oh, by the way, anybody ever been to Mesa Verde? And that, by the way, is a tunnel. This here is the track going in, the track going out. Well, that's my recreation of Mesa Verde.
I thought that's what it was.
Yeah, actually, it's the same building arrangement that I took from pictures. Those are made out of styrofoam and that I've preserved. Slope. Look at this old silo. Okay. Now they have those nice white concrete cube ones. Okay. This one was a turn of the century. Look at how steep that roof is. They didn't have to repair it very often because rain, snow, hail would just shuck off of it. Okay. Of course, it was real hard to get those shingles on there too. What about the Kansas Turnpike? Why didn't they just go straight from here to where that road is, make a cut right there, and just go straight up there? because it would have been steeper than the turnpike regulations allow. So they increased the run with these curves. Those are kind of huge switchbacks. Speaking of switchbacks, now that doesn't happen to be in the US, but can you imagine trying to go from down there to straight up here in anything? A tank couldn't make that, an armored tank. Well, there's the same road actually. You can see how they increased the run compared to the rise. That's in California. And turn your book, your packet to this page. I don't remember the page number on it. Someone who found it, announce the page number. 7. 7? Okay, well, that should have been easy to find if you went the right direction. Okay, here's your textbook for tonight's lesson. Okay, also when you're doing ALEKS. Hopefully we'll get through all of these tonight. We'll see. Here's the slope formula. You notice I said earlier, it doesn't matter which point you start with, as long as you're consistent once you start. Okay. Here's our workhouse formula. We call the slope-intercept equation, or just simply y equal mx plus b. M is the standard letter we use to represent slope. Why? I'm not really sure, but it is. Okay. This one's called point slope equation, and we'll talk about it. Here we've got the horizontal and vertical lines we already talked about. Okay, and then we're going to talk about perpendicular and parallel lines in a little bit. So I've got 2 points. I need to know the slope. Now they're going to call this point 2 and point 1. And you would work it like that. Now, notice here that formula said the first one minus the second one, right? First y value minus the second y value. That's why we got this plus here, is because we had minus a negative. This was minus a negative. So what they do here, we take the y values, -8 minus +3. Down here, +1 minus -2. Which simplifies to a -11/3. That means that you're going to go downhill, kind of like this, fairly steep actually. And you're going to go down 3 units for every 3 units you go sideways. Now, about that number. That number, 11 over -11/3, this would mean that you go down 11, right 3, because technically there's a plus sign there. This means the same thing as 11 over -3. But this time, you can go up 11, but left 3. Like the negatives are on the left side of the number line, okay? Or both of these are simply equal to -11/3. So anytime you've got a slope that has a negative in it, any of those 3 possibilities would work. Okay. Now, I said it doesn't matter which way you go. What if I call this point 1 and I call this point 2? Well, m equals y2 minus y1 over x2 minus x1. So it equals, in the way I'm going to do it, 3 minus -8 over -2 minus 1. I think it's easier to just go left, right, left, right. Okay. But either way will do it. Let's finish this out. This 3 minus a negative becomes plus a positive. So we have 3 plus 8 is 11 over -3. Okay. So it doesn't matter which point you use as your first point, as long as you're consistent once you decide. They just make numbers harder, all done. Okay. They're going to call those point 1 and point 2. I would do it the other way, but we'll do it their way. Here you get 1.3 minus -0.4. Minus a negative makes the positive. Okay, for the x's, 0.8 minus 1.2. Okay. Well, this plus that gives you 1.7. This minus that gives you a -0.4. Well, that simplifies if you multiply 10 times both of these to -17/4. And that's what you would use to actually graph with. Well, actually, you wouldn't even use that. 4 goes into 17 4 times, 1 left. So it'd be 4 and 1/4. You follow me? 4 and 1/4 rather. So that's what you would count perhaps in graphing. Now, here, 2 more. Do you need me to work those or not? Anyone want to see one of them? Okay. Slope of a horizontal line. Okay, we've already talked about these are horizontal line because y is a constant. Y stays the same. Okay. It has a slope of 0. Now, that could be 0 over 20. It could be 0 over -4 because it's still 0. Okay. Now, here's just an example. In other words, the y's are always going to cancel each other out on a horizontal line. Okay. What about a vertical line? Now, on a vertical line, it has a slope that's undefined because the x values will always cancel each other out. And anytime you have a 0 there, it's undefined. Okay. Now then, y. Whoops, went too far. Line.
Because you can't divide anything by 0, so.
That's true. But what does that mean? What does it really mean? Graph paper. Okay. If I have a slope of 3 over 1, and I start at this anchor point, okay, that means I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and I'm gonna have a line like so, right? What if I have a slope of 10 over 1? I'll call that slope 1 and this one slope 2. Well, if I start at this same point, I'm going to go up 10 and over 1, and up 10 more and over 1 more, and I'm going to have a vastly steeper line, right? Well, what if I had a slope of 1,000 over 1? It'd even be steeper yet, wouldn't it? I mean, you might even hardly not be able to graph it steep enough. Or what about 1,000,000 over 1? Or 1,000,000,000 over 1? Or 1,000,000,000,000 plus 1 over 1? It is infinitely steep. Vertical line is. It's infinitely steep. This number just keeps bigger and bigger and bigger and bigger in the ratio. It's truly an infinite slope, but you will never see that phrase in a math book. Okay? But for understanding it, that's why it's an undefined slope. Now let's do some ground rules. If I ask you on a test, okay, what is the slope of a horizontal line? You better tell me 0. Either in numerals or in words. Okay. I would like for you to also tell me that it is a horizontal line. Okay. If I ask you about a vertical line, what I expect you to write to me, one is that it's a vertical line, and two, that the slope is undefined. Okay. Now, the words I want to see come out of you, what is no slope mean? Does that mean it's infinitely steep so you can't measure it? Or does that mean it's levels so it's 0? So no slope is a confusing term in this circumstance. Never use it. Fair enough? Okay, now, we've already talked about this, we talked about that. Now we're going to deal with these generally. Here's a generality. If the line goes up left to right, you're going to have a positive slope. If the line goes down left to right, you're going to have a negative m value or slope. Okay. Now, slope-intercept form of a line. Y equal mx plus b. That's on your page 7. Okay. This is the workhorse form that we're going to use stuff. The m stands for the slope, which we just figured out how to do a moment ago. The b is the y value of the y-intercept. Now watch out, because I get tricky on my test. I'll give you a problem, and you see what the b is. Let's call it a 6, just for calling it something. Okay? And I ask you, what is the y-intercept? And if you just put down the number 6, that's a -2 automatically. But if you put down the point 0.06, then it's full credit. You see what I'm saying? If it uses the word y-intercept, then you've got to give the answer in point form. If it just says, what is the value of the y-intercept, or the y value of the y-intercept, then you could just say 6 in my example. Now, What if you got this problem and you need to graph it? Before we did it by doing an XY table or substituting the zeros, right? And basically what we did was this. Before, let X be 0, let Y be 0, and figured out the two values to go with it. Now, in this case, what we want to do is convert this into Y equal mx plus b. That means isolate this Y, get that X's on the other side. Okay, so the first thing I'm going to do is I'm going to add 2x to both sides. And when I do that, I have 3y equals 2x minus 6, putting it in descending order. Now, I'm going to divide both sides by 3. Every term. Don't do it like this. Do it like this. Because this becomes slope. Y equals m x plus or minus. In this case becomes 2 because it reduces. Okay. Now, this becomes very easy to graph. So let's do that. Yes, should be a -2. Because I divided by a positive. Okay, so this generates the point 0, -2, right? That y-intercept value. So here's 0, -2. That becomes my anchor point for graphing. Here is my slope. Obviously, I'm making mistakes tonight. So I can almost started to do it again. 2 over 3 or -2 over -3 are my choices for slope. This, of course, goes up, right. This, of course, goes down, left. But starting at that -2 again, right here, I go up to 1, 2 over 3. 1, 2 over 3. About there, down to left 3. And my line. Now, you okay?
Yes.
Thank you. If something's kind of bugging you or confusion, stop right then. Okay, well, this is just doing what I already did. Okay, another one. Now, this one is not in y equal mx plus b format. So we need to rearrange some stuff. We need to take this 4 over here and divide both sides by -2. And we get that. So our slope is -1/2, which we can show as -1 over +2 or +1 over -2. And our y-intercept is the point 0, 2. Okay, so my anchor point is the point 0, 2. I go down 1, right 2, down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2, and so on, and then draw the line. Go back. You ready? Yes. Okay. So if you got this, what do we do? Write it in slope-intercept form, figure out the slope and the y-intercept, and then graph them. Pretty simple process. Now, we're gonna take up something new. Now find the point slope formula on your sheet. Find the point slope formula. Okay, the point slope formula looks like y minus y sub 1, they might use a 2 there, equals m times x minus x sub 1. Okay? This y sub 1, x sub 1 refer to the coordinates of this point. The m refer to the slope of this. Okay? So if we want to solve this, then I would like for you to always write the form of the equation. You do that much and you got 1 point. Minus 3 equals the slope, in this case 5, times x minus negative 2. Do I need to put that in a parentheses for you, or are you okay? Now, you get this far, you got 2 points, even if you mess up after that. Because that shows me that you understood the basic function of write the equation of the line. Anytime you see the sentence, write an equation of the line, you're going to use that formula. Okay? Every time you see that statement, you're going to use that formula. That's a memorized formula. It'll be on my test multiple times. It will be on the final multiple times. Okay. Well, as we go down through this, now I'm not going to let you do it the way they're showing it here. I don't like this way. It's easy to make errors. This is a consistent way that'll not only work for this, it'll work for parallel, it'll work for perpendicular, and so on. Whereas that way they were about to show you only works on isolated problems. I want to finish this problem before we leave. Okay, here, so I've got y minus 3 equals 5x plus 10. Okay, I'm going to take this 3 over to the other side, plus 3 plus 3. By the way, if either one of these two numbers are a fraction, then you're going to have to play the common denominator game. Okay. Well, in this case, they're not. So I've got y equals 5x plus 13. That is my slope-intercept form equation. Now, this one didn't ask me to graph it. But had they asked me to graph it, my slope is 13, my y-intercept is the point 0, 13. Okay, that becomes my anchor point. My slope is 5 over 1 or negative 5 over negative 1. Okay, so from this point, I can go down 5 and left 1. I can go down 5 more and another 1 and 5 more and another 1, or I can go up 5 and right 1 and another 5 and another right 1. There's my line. Notice positive slope, uphill left or right. We'll stop tonight. So have a good weekend. No, today's Tuesday. Thursday.